Hello, this is Mark Siddall, and welcome to a short little focus finder. Now, this first slide, it's a capital mistake to theorise before one has data. Now, I find this actually in a footpath down in Plymouth, but I think it's a quote from Sir Arthur Conan Doyle's detective, Sherlock Holmes. Now, I think that the quote really applies very much to buildings as we know them these days, because we've got a lot of theory going on about how buildings should perform, and we've got a lot of different standards which set theoretical targets, but we have got very little data about how they're actually performing in practice. So, this means that we've got a very weak evidence base to support the designs that are actually being promoted by various different standards. And as Jas Wingfield said when he was at the Centre for Built Environment at Leeds Met, until we can get the processes right and have robust ways of checking and verifying performance, then the targets themselves become secondary. There's no point having all of these guidance notes, regulations and things if we don't actually have the evidence base to support the fact that they actually work and they can be delivered on the ground. And this was exemplified by Leeds Met studies down at the Stamford Brook project, whereby they identified party wall bypass, which has now been addressed in theory in the building regulations. We're now meant to be putting insulation into the party walls between properties to help prevent convective bypass. But is this happening in practice? Well, there's a good amount of evidence that I've seen to suggest that it's not happening consistently, or it's happening poorly. So we've got to be very much aware of this potential gap between theory and practice, and it really goes back to making sure that the designers and the contractors on sites really understand building performance related criteria and how to deliver that in the most appropriate way. And regulations themselves are not always what's necessary. The building regulations say that we should ensure that the buildings will perform appropriately, but we're not actually making sure that the designs conform properly with the energy models and the likes that actually take place. So you can't you can't manage what you can't measure. So you've got to make sure that you get things right. So you've got to be very careful about things like passive house principles, whereby people are taking loose interpretations of something they've read in the media or a magazine or something online, and it's been they've taken the headlines. They've not necessarily got the qualifications, the depth of knowledge, or the understanding to be aware of the principles, the concepts, and the actual research that backs up why certain decisions are taking place, and how the whole process actually works. Now, this is really key, because when we start to think of actual delivered performance, then, the graph that we're now looking at shows the results from coheating tests. Now, a coheating test is a measure of the whole building U value, the actual physical heat loss from that property. And what you can see is the predicted performance in blue and the measured performance in red. Now, the red line always goes higher than the red line is always higher than the blue line. The measured results are always worse than the predicted. And often as not, it's between something in the order of 20 to 50%, 70%, that sort of thing. And what you've got over on the right hand side, though, are some houses that start to buck the trend, because even though there is a deviation, you're actually within measurement area of the coheating test itself. And the way that this was done was not simply by addressing the passive house standard. It was also achieved by looking at the gaps that existed within UK building regulations and within the passive house standard and seeking to address those. So there's a more rigorous approach that's required based upon a lot of research-based evidence. And that was a level of work that had to go into making sure that these properties were going to work in the appropriate way. So you've got here some examples whereby you can close the performance gap, but you've got to have a lot more understanding about how to design and build buildings appropriately. And it's important to recognise that the coheating tests are done without building occupants in place. So therefore this is not the same as somebody driving a car, should we say, and accelerating, and different people using different buildings in different ways, or driving cars in different ways. We've got a standardised method here which is looking at how the building performed, the fabric performed in practice on site over a certain period of time. And this was one of the longest coheating tests that have ever been undertaken, so it's one of the most accurate and reliable results that Leeds Met have ever had the opportunity to provide and generate. So this is really key. Now, what you've got, this moving things forwards from domestic over to non-domestic. Now this is a slightly different story here. We're now looking at measured use over periods of a period of a year, rather than a measurement of the physical fabric itself. But what we've got is we've got a whole host of schools and university buildings. And what you've got is you've got UK Academy buildings working up our way from the bottom. We've got UK Academies and the likes, with a whole host of different performance standards actually being achieved in practice. So these are the measurements. So we've got the heating and the hot water, the electrical energy use, the heat for refrigeration and heat rejection, pumps, fans, controls, all these kind of things, lighting, the lights, all these things have been tabulated out. And you can see how some of these schools are really using a lot more energy than some of the other ones. And at the top of the graph you find that you've got the Riedberg school, which is the actual measured performance of a passive house school that's been constructed in Germany. And then you've also got the measured amount, the passive house guidelines in terms of seeking to reduce carbon emissions, or in passive house terms we've been talking about primary energy, but it's been converted to carbon emissions here for the purposes of the graph. And you can see how the school is actually performing better than the design target. But if we were to look at the BSF PFI kind of operational targets that had been set for these different projects, then you've got that's 27 kilograms per metre square per annum, which is significantly different. There's not one school in the UK or one educational facility in the UK that's actually hitting these kind of targets. And then you've got to bear in mind that but 2018 the operational target is still at targeting 0, and we've got some real issues there if that's going to be addressed, and making sure the design is right and understanding how all the interactions between the fabric and the internal gains and the various different pieces of equipment that have been brought into a building really start to play a key part. So we need further closer design, closer analysis. We need more evidence within our design processes to get this right. And then if we go back over to thinking about residential design, or in fact any kind of design, as we're making buildings more airtight and we're really becoming increasingly reliant upon mechanical ventilation, then we've got to make sure that the acoustics are done right. So here on the right we've got some acousticians. We've got Jack Harvey-Clark and a colleague from Apex Acoustics, and they measured the in situ noise levels at Racecourse, and what they found was that because of the attention that had been paid to the design and the quality of the install, that the noise levels were well within targets that had been set for the design. However, it's worth noting that we were targeting less than 25 dBA, whereas within the living spaces, whereas building regulations target less than 35 dBA as a recommendation, not a requirement. Now, what that would have meant was, if we'd have actually designed to the building regulations, all the measurements in terms of comfort criteria for noise suggest that 50% of people would have been experiencing discomfort, as opposed to in the completed design, whereby there's no reported discomfort from the noise from the ventilation systems. The measurements suggested that less than 10% of people would experience any kind of discomfort. And this is actually exemplary performance. Over on the left we've actually got another passive house project that I've been involved with, Steel Farm up in Hexham, and this just shows an installation of an MVHR unit, the appropriate insulation that we've got onto the intake and the exhaust, so that we don't get condensation, mould growth and potential damage to the building fabric itself. And also this insulation helps to avoid thermal bridging that's caused by the cold external air being brought into the MVHR unit itself, because this is all located inside the property. And just in the background you can see an attenuator in there as well. So we've got the performance gap. It isn't just about energy. There's acoustic issues to consider as well, as indeed there are issues associated with comfort and the likes. But in installing ductwork into properties, we've got to make sure that the ductwork's appropriately clean, because without that then we're getting pollutants and contaminants in there which can have an adverse impact upon the health and well-being of people that are living in properties. And in fact, sick building syndrome was kind of first recognised in office buildings as well. So we've got to make sure that the design is, that it's not only the design being right, but it's making sure that the execution is right and making sure that people understand what should be done. So what we don't want is what you see over on the left-hand side here, whereby all the ductwork is getting dirty, and what we want to make sure of is what we see over on the right, where all the ducts are being capped, stored in the appropriate ways, and then when they're installed they're capped off as well, so that we aren't getting contaminated debris and the likes into the ductwork. So I hope you found this little video useful and interesting, and if you want to get any more information about evidence-based design, then please punch in your details down below, and I'll be happy to keep you up to date as and when I make more information available. Okay, thank you very much for your time, and I hope to be in touch with you very soon. Cheers.